What's up, everyone? This is LeetCode 8, string to integer. We've done this problem in Python. Now we're going to do it in C++. So we just have to convert a string to a 32-bit signed integer. Seems simple enough, but we have a bunch of edge cases we have to handle, and that's kind of the tricky part about this problem. One of which is we have to ignore leading white space, right? So for example, here we have leading white space in our input string, and we have to ignore that. Two is determine the sign. So we could have a negative sign or a positive sign, and we have to basically account for that. We could also have neither, in which case we have to assume the number is positive. And three, we have to basically convert the integer, or convert to the integer properly by basically skipping the leading zeros, as well as reading until the end or until we encounter a non-digit character. So for example, here we're reading 1, 3, 3, 7. Oh, we hit a non-digit character, right? So technically we only read up to here. And that's why our output for this problem is 1337 instead of something like 133703, right? And basically we could have no digits also, in which case we just return 0, okay? So a lot of little edge cases we have to handle, as well as our integer could be out of the range of 32 bits, in which case 32-bit signed integer range, in which case we have to clamp it. So if we're less than whatever this is, we have to basically return this. If we're greater than whatever, our result is greater than whatever this is, we just have to return this, so that we're clamping the result to the boundaries if it's outside of those boundaries. Okay. And yeah, I don't think this problem is too hard. It's just that there's a lot of edge cases. Well, I guess that does make it hard, but I mean, like, it's not that hard. The answer, the final answer, the final code, the final solution is not that hard to wrap your head around. It's just a lot of little edge cases, but I think you'll understand. Okay, so the way we're going to do this is we're going to start at the 0th index, and we're going to basically move that. Basically, have like a pointer, and we're going to move that forward and handle every character in the string. Okay, so let's have an int I, and we're going to set that at 0, the 0th index, and we're also going to get the length of whatever s is, right? So this. And now we're basically going to strip the white space. And the way we're going to do that is basically while the I is in bounds, right? And whoops, while the I is in bounds, and basically we have white space, which we can check by doing this, right? While that's the case, let's just move I forward. Okay, pretty simple. So we handled that case. Now we need to handle the sign. Okay, so we're going to do int sign by 1, and we're going to do while I is in bounds and whatever character that we're on, s of I, if that's a negative, we need to flip the sign and move I forward, right? We're gonna do else if we're in bounds and s of I is positive, then we just move forward. So I'm gonna explain this. This is kind of weird, right? Because okay, let me think how to explain this a little bit clearly so you don't get confused. We have a sign, right? Which is 1. If we have a negative, if we encounter this symbol, which is a negative symbol, we want to put sign as -1, because at the end, we're going to have some result, and we're basically going to take result and multiply it by sign. So if result should be negative, it'll be negative once we do that, right? So why do we have this else if statement if we have sign at positive initially, right? Like, that's our base assumption. And the reason is because, remember, we can have a negative symbol, we can have a positive symbol, or we can have neither. That makes sense? So we could have something like -42, we could have +42 as our input, or we could have 42. The reason we have to do it this way is because it accounts for all three. So for example, if we have this negative here, sign is equal to -1, we do that, and then we move the I forward so that we move to here. Now let's say we're here. Well, if we're here, we just move the I forward, right? Right? Okay. But the reason is, if we have something like this, where we have no plus symbol or negative symbol, the reason we need to do it this way is because in this case, we don't want to move the I forward because, I mean, we're not at a plus symbol. We're going to be here, right? We never even encounter a plus or a negative symbol. So sign will still be 1, but we're not actually moving the I forward in this case, right? So that's why we need to do it this way, okay? I hope that makes sense. I think it does. So we basically have like 3 little edge cases we have to handle. Okay. So now we can handle the digits. Okay. And first of all, we're gonna use long result 0, right? Um, you can use a long to detect overflow. I don't think I need comments for this. Honestly, it's just simple stuff. Okay, so what we're going to do now is we're gonna basically check if we're in bounds. Okay, and s of I is a digit, right? As we move forward, if that's the case, we're gonna do result is equal to result times 10 plus s of I. Okay, so we're basically taking s of I and converting it to int, right? So what this is doing, if for some reason you don't understand this, I'm not sure why you wouldn't, considering this is a medium problem. We've done harder problems like this. We've done a problem like this already, where we have to do something like this, but if for some reason you don't remember, it's okay. What we're doing is basically result is 0 initially, right? The result is 0 initially, so we're doing 0 times 10 plus s of I, which is 4, right? Because we're at the 0th index. And that 0 times 10 is 0, plus 4 is 4. Okay, we move on to the second 4, right? So result is what? 4, 10 plus that second 4. So 4 times 10 is 40, plus 4 is 44. Okay, then we keep going in the while loop, right? We're at the 3 now. So result is what? 44 times 10 plus 3, and we get 443. So as you can see, we're building out our number in this while loop, okay? Now, because this is a condition here that it has to be a digit in order for us to keep going the while loop, we're going to skip, or we're going to exit the while loop if we have something like this, like when we encounter the C here, right? So we don't have to worry about that. Also, let's consider a case where we get something like 044, right? Well, in that case, we would have something like 0 times 10 plus 0. Well, that's 0, right? Um, result is still 0. Then we move on to 0 times 10 plus 4. That gets us 4. Then we have result is 4 times 10 plus 4. So you can see, even in these cases, we have this case where we have a leading 0, we still build out the proper result, right? So this might be our input string, but our result at the end is 44, which is what we should expect, okay? So we handle those cases. So that makes a little bit sense, hopefully. Yeah, that's not too bad. And then we can honestly, you can do it outside this loop if you want, but we can you can do it outside of this loop if you want, but we can just keep going in this loop, which is that if sign is equal to 1 and the result is greater than int max, return int max, right? We're doing the clamping in here basically. You can do it a lot of ways, like you can do it outside of this while loop if you want. It really doesn't matter, but just make sure you handle the clamping, right? Because it is important if you're outside of the 32-bit signed integer range, you need to make sure you do the clamping if your actual result is outside of that range, okay? You can do it in here, you can do it outside. I mean, I think in the Python video I actually did it outside, but you can do it in here as well. Oh yeah, and by the way, don't want to forget this important part. We want to make sure we move the I forward after every after we handle whatever digit that we're on. Okay. And then if we hit this return statement, it means that result is in bounds, but we can't return result. We have to return result times sign, right? Because sign could be negative, so we want to make sure if it's in bounds, but we convert result to a negative number if it should be negative. Okay. I think that's okay. I don't think I made a mistake, but we'll see. Yeah. So like I said, this problem is not that hard. It's just, I don't know, it has a lot of edge cases. I really like, I think I've said it before because we've done these types of implementation problems before. I'm not a big fan of these personally because I feel like there's no algorithmic trick or learning that you do. It's just like handling a bunch of edge cases. I don't know. Maybe you like these problems, maybe you see the value in them. I guess it teaches you how to solve this type of problem, but I don't know. I'm not a big fan of these personally. Um, but we're doing it because it's on the Grind 75 list. But yeah, I hope this helped, and I'll see you in the next one. Peace out.